Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about solving one- and two-step equations. So the whole purpose of solving an equation is to get the variable, which is the letter, all by itself. Okay, so our first equation, I have m plus 12 equals 10. And I want to figure out what does m have to equal so that if I add 12 to it, I'll get 10. All right, so I like to draw a line down my equal sign to kind of separate the two sides of the equation. All right, and then an equation has to be balanced. So whatever you do to one side, you have to do to the other. So I want to get m by itself, and it's connected to a 12 by addition. So I'm going to use the inverse operation of adding, which is subtracting, and I'm going to subtract 12 on both sides. So now if I have 12 and I take 12 away, that's going to cancel. It's going to become 0. So I'm left with m equals 10 minus negative 12, or 10 minus 12, which is negative 2. All right, the next one, I have negative 2 equals g minus 9. So I'm going to separate the two sides. I'm trying to get g by itself. It's connected to a 9 by subtraction. So I'm going to add 9 to both sides. Whatever I do to one side, I have to do to the other. Negative 9 plus 9 becomes 0, so that cancels. And then if I do negative 2 plus 9, I get 7, so g equals 7. All right, the next one I have negative 7y equals negative 91. I want to get y by itself. It's connected to a negative 7 by multiplication. So I'm going to get rid of it by dividing both sides by negative 7. Negative 7 divided by negative 7 becomes 1. So that's going to cancel out, and I'm just going to have y equals. Now, a negative divided by a negative is going to become a positive. And so 91 divided by 7 gives me 13. So y equals positive 13. All right, the next one I have a over 9 equals negative 4. I want to get a by itself. It's connected to the 9 by division. So to undo the division, I'm going to use multiplication. So I'm going to multiply both sides by 9. And that's going to become a 1. And so I just get a equals negative 4 times 9 would give me negative 36. All right, if you have fractions and you need to get rid of a fraction, you're going to multiply by the reciprocal. All right, so I have 2/3 k equals 10. I want to get rid of that 2/3. So I'm going to multiply by the reciprocal. So that means I'm going to take the 2/3 and I'm going to flip it over. So I'm going to multiply both sides by 3 over 2. And remember, whatever you do to one side, you have to do to the other. And if I multiply 3 over 2 times 2 over 3, I get 6 over 6, which simplifies to 1. So that's going to cancel. I'm going to make the 10 into a fraction by putting a 1 under it. And then I can go ahead and multiply fractions, top times top, over bottom times bottom. So 10 times 3 would give me 30, and 1 times 2 would give me 2. So I have k equals 30 over 2. 30 divided by 2 becomes 15. So k equals 15. Let's try another one. So I have negative 6/5 m equals 12. I want to get rid of that fraction in front of the m. So I'm going to multiply by the reciprocal. Okay, which means I'm going to flip that fraction over. All right, so I had negative 6 over 5, and when I flip it, I get negative 5 over 6. It doesn't really matter where you put the negative, put it in the top, in the bottom, or out front. I like to keep my negatives for fractions in the numerator. And so I'm going to do that to both sides. So I'm going to multiply by negative 5 over 6. On the left, it cancels out. On the right, I'm going to turn the 12 into a fraction by putting a 1 under it. Multiplying fractions, no big problem. Top times top over bottom times bottom. I get negative 60 over 6. And then when I divide negative 60 divided by 6, I get negative 10. So m equals negative 10. All right, so let's look at some two-step equations. Again, I'm going to go ahead and draw that line down the equal sign. And I like to get rid of whatever's furthest away from the x first. Okay, you're going to want to probably use like in opposite of your order of operations. So you're working backwards of that order of operations. So you're undoing the addition or subtraction usually first, and then you're undoing the multiplication or division. Okay, but I always like to start with whatever's furthest away. So I want to get x by itself. It's connected to a 6, and it's connected to a positive 8. The 8 is a little further away, so I'm going to get rid of the plus 8 by subtracting 8 on both sides. All right, I'm left with 6x equals 42. 50 minus 8 gives me 42. Now I want to get x by itself. It's connected to a 6 by multiplication. So I'm going to divide by 6 on both sides. That cancels, and I get x equals 7. All right, this one I have 7 minus 3y equals 34. I'm trying to get y by itself. So on the left side is where I have the y. The 7 is further away, and it's a positive 7. So I'm going to subtract 7 on both sides to get rid of it. 7 minus 7 becomes 0. And then I'm left with negative 3y equals 27. I want to get y by itself, so I'm going to divide both sides by negative 3. That cancels. I get y equals 27 divided by negative 3 would give me negative 9. All right. The next one I have x divided by 2 minus 7 equals 9. All right, the 7 is a little bit further away from the x, and I would get rid of that by adding. So I'm going to add 7 to both sides. I get x over 2 equals 9 plus 7 would give me 16. Now I want to get rid of the 2, so I'm going to multiply both sides by 2. Those cancel. I get x equals 32. The next one, I have negative 10 plus 7/4 p equals negative 38. So I'm trying to get p by itself. The negative 10 is further away, so I'm going to add 10 so that they cancel. That leaves me with 7/4 p equals, I have negative 38 plus 10. That's going to give me negative 28. And then I'm going to multiply by the reciprocal to get rid of that fraction, which means I'm going to flip the fraction over. So 4 over 7. I'm going to turn the 28 into a fraction by putting a 1 under it. Multiplying fractions, no big problem. Top times top over bottom times bottom. I get negative 112 over 7. Negative 112 divided by 7 gives me negative 16. All right. 11 equals c divided by negative 5 plus 8. I'm going to draw my line. I'm trying to get c by itself. On the side that there's the c on the right, the 8 is further away, so I'm going to get rid of the 8 by doing the inverse of adding, which is subtracting. 8 minus 8 cancels. 11 minus 8 becomes 2, so I have 2 equals c over negative 5. So I want to get rid of the negative 5. It's connected by division, so I'm going to multiply both sides by negative 5. Negative 5 times 2 would become negative 10. And on the right, the negative 5's cancel, and I just get c. So c equals negative 10. All right, this one, I have n minus 5 over negative 2 equals negative 7. All right, so the dividing by negative 2 needs to go first. So I'm going to multiply both sides by negative 2. All right, those cancel. I'm left with n minus 5 equals, a negative times a negative makes it a positive. 7 times 2 is 14. Now I want to get rid of the 5, so I'm going to add 5 to both sides. And I get n equals 19.